Okay, so this is an example, another example, and when I start highlighting the information, we'll look at what the pertinent information about this example is. So back to uniform rods now. Go. Length, mass, so we're given the mass, not the weight. Resting, horizontal support, so we've got some supports going on here. It's a bit thicker. We've got a particle at M, and we've got probably the most important information here, which is that it's on the point of tilting about D. Okay, so let's start with a diagram, some variety. Rod-ish. So it's AB, make it a little bit longer. A, B, length 4, mass 12, support C and D, so A to C and B to D. So this then is going to be point C, and then B to D, call it D. Particle is placed at B. Put that on. So these are both 0.5 in from the end by the look of it. This is particle. We'll call it M. We've got, so it's uniform, so the weight is going to act in the middle. So that's 1 meter in from either side, so we're going to need another 1.5 meters on either end to find the middle. And then we're going to have the weight acting from the center. So we have a weight acting there. So the mass is 12 kilograms, so the weight will be 12 g. This one has got a mass of m kilograms, so it's going to have a weight force of mg, and then these are going to have reaction forces going upwards. Doesn't say they're the same, so we're not going to assume they are, so we'll call it RC and RD. And the key here is on the point of tilting. Okay, so I think this is the only one at the moment in the notes that's quite like this. So basically means we have to take moments around the point it's talking about there. So it has to be moments about D, and at that point, if we take moments about D, and it's going to tilt at this point here. Now, first of all, this reaction force is not going to act because it's happening at that point. It's tilting around there. But if it's about to tilt around this point here, it's going to be kind of not in contact with that support either. So at that point, RC would equal 0, as well as the fact that RD is not going to be relevant because we're taking moments around that point. So we could, look at moments of forces up and forces down and all that kind of stuff, although we need to be a little bit careful with the tilting ones. But instead, for now, I'm going to take moments around point D. I don't need the plus sign. So I'm going to look at clockwise moments first. So if I'm tilting from here, this mg is going to be going clockwise. So I have mg multiplied by the distance of 0.5. So there's 4 forces in total. That one's acting that one. That one's not going to be relevant because we're taking moments from it. That one's going to be 0 because we are on the point of tilting. So this is going to basically kind of have no pressure in contact with it. It's not quite going to be lifted off the support, but it's going to kind of have that no support. If you imagine pushing your hand down the table and then it's kind of the point just before it comes off the table, you're not going to have that reaction force, that kind of pressure or contact force, if you will, because we're losing contact force. And then anti-clockwise, got this 12g multiplied by the distance of 1.5, and these are going to be equal since we're on the point of tilting, we're in equilibrium still. So we've got 0.5 mg equals 1.5 times 12, 18g. The g's are effectively going to cancel out or be irrelevant, so 0.5 m equals 18, so m is going to equal to 36 kilograms. Okay, which you could, I suppose, leave in terms of g, but this is nicer.